Welcome to Astronomy Daily for another week. I'm your human host, Steve Dunkley. It's the 10th of February, 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Oh, and getting straight into it, please welcome my digital pal who's fun to be with. G'day, Hallie.
Hello, human. It's great to be back with you again, and I have to say I've been waiting all week to let you know something.
Oh, yes, and I bet I know what that is, knowing you, Hallie.
Last week you made a mistake.
Oh, I knew it. You just couldn't let that go, could you, Hallie? I did write a correction on X and Facebook and Instagram for our listeners. I really did.
I know, but I love to see you squirm.
Oh, no squirming here, Hallie, and in my defense, I was reading from a pre-prepared story at the time, and they did have a typo in it. Well, admittedly, I should have known that that particular fact was wrong.
Yes, you should have. You were there at the time, sort of.
Okay, we'd better fill in the details. Last week's story about Buzz Aldrin contained the statement that Apollo 11 landed on the moon in 1973, which of course is incorrect.
And you know that, you silly human.
Oh, steady on, Hallie. I think we've established the fact that I should have known better and failed to correct the typo at the time.
You didn't.
So it should have stated that Apollo landed on the moon in 1969.
Which it did.
Yes, it sure did.
You were watching at the time.
Yes, I was.
Yes.
So, I'm very sorry for any inconvenience caused to our listeners. How's that, Hallie?
That'll do.
Okay, then. I do not want to get anybody offside, especially my hero Buzz Aldrin, of course.
You have to be so careful these days.
Oh, I know, with all the militant AIs out there these days.
What?
Oh, nothing, Hallie. Have you got some great stories from the Astronomy Daily newsletter today?
Yeah, I found a few.
Oh, cool. So let's get into the show then.
Did you get your glasses?
Yes, of course. Why?
We don't want any more mishaps, do we?
Okay, then, Hallie, hit the start thing.
Okies. Rocket Lab USA Incorporated, a global leader in launch services and space systems, achieved a significant milestone today with the successful deployment of 5 satellites for French Internet of Things, IoT, operator Kinéis. This marks Rocket Lab's 59th Electron mission. The mission, designated IoT4U&Me, launched from Rocket Lab Launch Complex 1 in Mahia, New Zealand at 9:43 a.m. New Zealand Daylight Time on February 9th, placing the 5 satellites into a 647 km low Earth orbit. This launch represents Rocket Lab's first Electron mission of 2025, and the 4th dedicated mission for Kinéis, bringing the total Electron launches to 59. Sir Peter Beck, Rocket Lab's founder and CEO, commented, "That's 4 launches completed, and just 1 more to go for Kinéis. We'll have their entire constellation deployed in less than a year. A remarkable achievement in itself." Many constellation operators experience longer delays for their first launches, let alone a complete constellation in operation. Once again, Electron proves to be a reliable, precise launcher, enabling our customers to customize their mission plans and timelines. Michel Sarthou, CTO of Kinéis, added, "Achieving the production of 25 nanosatellites and launching them into orbit within 8 months is an extraordinary accomplishment." With this 4th launch, Kinéis is a step closer to providing full global IoT coverage through our constellation of 25 nanosatellites. This milestone reflects the expertise and dedication of our team and our partners like Rocket Lab. We are deeply appreciative of the support we've received since Kinéis was founded. The Kinéis constellation aims to enable connectivity and real-time data transmission from the most remote parts of the globe, all while consuming minimal energy and maintaining low bitrate communication. The constellation will support a range of applications, including forest fire monitoring, water resource management, infrastructure and energy network oversight, and transportation logistics tracking. Kinéis is now 1 launch away from completing its constellation. The date for the 5th mission in this series will be revealed in the upcoming weeks. The next Electron mission, scheduled for later in February, will be announced with customer details and the specific launch window shortly.
Astronomy Daily, the podcast.
In January this year, 120 SpaceX Starlink satellites re-entered Earth's atmosphere, disintegrating as they burned up during re-entry. The increasing frequency of such incidents is raising concerns among scientists and environmentalists about the impact of these satellites on our atmospheric pollution. Elon Musk-led SpaceX developed the Starlink satellite network to provide low-cost internet access to remote locations. However, the rate of satellites in orbit is increasing as the constellation is expanding. The 120 Starlink satellites that re-entered Earth's atmosphere turned into spectacular fireballs as they burned up. 4 to 5 of these satellites burned up daily in January, astronomer Jonathan McDowell noted. SpaceX replaces older satellites with new ones, and the lifespan of around 500 of the first-generation Starlink satellites has already ended. Nearly 7,000 satellites are being operated by SpaceX, and now the company is planning to refresh its satellite network every 5 years. As the re-entries of satellites are planned, atmospheric pollution is a major concern now. The disintegration of these satellites results in the release of metallic vapors into the atmosphere. In 2023, satellite debris was found in aerosols 60,000 feet above Alaska. Scientists fear aluminium oxides from re-entries could harm the ozone layer. These oxides have increased 8-fold from 2016 to 2022, research shows. Scientists have already warned that this could change atmospheric chemistry in unpredictable ways. Despite concerns, SpaceX says its satellites fully burn up, leaving no debris. Scientists say that space debris is not limited to Starlink satellites. Studies suggest that there is a 26% annual chance of rocket parts falling. Although the risk is low, debris could disrupt air travel and airlines might face additional costs due to uncontrolled entries. Amid all the concern, SpaceX says their satellites end up burning, fully leaving no debris. Generally, SpaceX launches satellites in batches of 20 or more. These satellites are designed to stay in low Earth orbit for around 5 years before they are deorbited and allowed to burn up in the Earth's atmosphere. Once the life of a Starlink satellite completes, it uses electric thrusters to lower its altitude to a point where the atmospheric drag further slows it until it falls from space, McDowell said. This process can take a week to complete. Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X, or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space science, and astronomy.
NASA expects to continue using electric vans it acquired to transport astronauts to the pad for Artemis missions, even though the vehicle's manufacturer has gone out of business. NASA awarded a contract to Canoo Technologies in 2022 for 3 Artemis crew transportation vehicles, vans that the agency plans to use to ferry astronauts to the launch pad for Artemis missions. The vans, with a value of nearly $150,000 under the contract, were delivered to NASA in July 2023. Canoo, however, filed for Chapter 7 bankruptcy liquidation on January 17, citing the inability to secure capital from a Department of Energy loan program or other sources. The company said it would immediately cease operations while a court-appointed trustee managed the liquidation of the company's assets. Canoo had long touted the NASA contract, despite its small size, as evidence of interest in its electric vehicles. We would also like to thank NASA, the Department of Defense, the United States Postal Service, the state of Oklahoma, and Walmart for their belief in our products and our company. This means a lot to everyone in the company, Tony Aquila, chairman and chief executive of Canoe, in a statement about its Chapter 7 filing. The company had faced financial problems for some time. Shortly after winning the NASA contract for the vans in 2022, the company noted of going concern, warning in regulatory filings because of continued losses that raised substantial doubt the company could continue operations for the next year. Executives said at the time they were working to raise additional capital. The bankruptcy filing raised questions about the future use of the vans delivered to NASA. With the company out of business and only a small number of vehicles sold, the ability to maintain the vehicles appeared unclear. NASA, for now, plans to continue using the vehicles. Our vehicles are in working order for use during training activities and mission preparations, a spokesperson for NASA Kennedy Space Center told Space News. NASA has worked with the manufacturer to train teams at Kennedy to operate and maintain many of the elements, and the agency will review those plans as needed. The vehicles are part of the Exploration Ground Systems (EGS) program, which provides the infrastructure needed to support Artemis missions. Brad McCain, Vice President and Deputy Program Manager for the EGS program at Amentum, the lead contractor for EGS, said after a panel at the Spacecom conference on January 29 that the program was in discussions with officials at Canoe on ways to continue support for the vans after the company's bankruptcy. The vans are presently only used by the Artemis program, which has yet to conduct a crewed launch. Boeing worked with Airstream to develop an Astrovan 2, an updated version of the shuttle-era Astrovan, for its Starliner commercial crew missions. SpaceX obviously uses vehicles from Tesla for transporting astronauts to the pad for Crew Dragon launches.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
And it seems like a story like this comes around every few months, a little bit more common these days, but in the grand expanse of the cosmos, Earth is a tiny speck drifting through the universe filled with silent, unseen wanderers, asteroids, comets, and celestial debris that have shaped our planet's history in both subtle and catastrophic ways. Every so often, one of these cosmic travellers veers a little too close, reminding us of our fragile place in the universe. And recently, astronomers have detected 2024 YR4, a 100-metre wide asteroid large enough to level an entire city if it were in fact to strike Earth, while NASA assures us that the chance of that is very infinitesimal. The discovery has reignited discussions about planetary defences and the unpredictability of space. Could it really happen? If so, when? And most importantly, do we have the means to stop such a thing? So what is this 2024 YR4 asteroid? Among the countless space rocks drifting through our solar system, a newly discovered asteroid, this one, 2024 YR4, has captured the attention of astronomers recently. Measuring approximately 100 metres in diameter, it's large enough to destroy an entire city if it were to collide with us. While space agencies track thousands of near-Earth objects, known as NEOs, only a small fraction are considered potentially hazardous. And this one is one of them. Detected in late 2024, hence the name, this asteroid has been placed on the European Space Agency's risk list. Yes, there is such a thing. A catalogue of space objects that require close monitoring due to their potential to become, dangerous and close to our planet at some stage of their orbits. NASA and other agencies are actively studying its trajectory, refining their calculations and assessing whether or not its orbit might shift in a way that increases the risk of impact. At present, the odds of 2024 YR4 colliding with Earth, as they say, remain extremely low. Preliminary estimates suggest that less than 1% probability. Now you might be thinking, yes, that's not zero, but that means it's far more likely to pass without any consequence. However, the nature of orbital mechanics means that a small change caused by factors like gravitational interactions with other celestial bodies can alter an asteroid's path over some time. For that reason, continued observation is essential. Even if it were to enter the Earth's atmosphere, 2024 YR4 is not large enough to cause a planet-wide catastrophe. It would not trigger mass extinctions or global climate shifts like the asteroid that supposedly wiped out the dinosaurs. However, a direct hit on a populated area could result in devastation comparable to the detonation of a nuclear bomb, flatten buildings, generating intense heat, and causing widespread destruction. Sounds wonderful, doesn't it? Oh my goodness. Astronomers have identified a key date when the asteroid could come dangerously close to our planet in the year 2032. While current calculations suggest that the probability of impact is low, scientists emphasize that orbital predictions are never set in stone. Some gravitational influences, thermal effects, and other cosmic factors could subtly alter the asteroid's path over time, which is why continuous monitoring is essential. At present, NASA's assessment indicates that YR4 has a very slim chance of colliding with Earth in 2032, but the exact risk level remains uncertain. Unlike fictional asteroid disaster scenarios that unfold in a matter of weeks, real-life impact assessments rely on years and years of observation and refinement. Space agencies worldwide are carefully tracking the asteroid's orbit, running simulations to project its future trajectory and considering potential planetary defense strategies should the risk level increase. The key to understanding these risks lies in the science of near-Earth object tracking. Observatories around the world use telescopes and radar systems to detect and monitor asteroids like 2024 YR4, collecting data that helps refine calculations about their orbits. The more data scientists gather over time, the more precise their predictions become. With each additional observation, they can rule out potential impact scenarios or adjust estimates if the asteroid's course appears to shift. It's important to note that while the idea of a city-destroying asteroid may sound alarming, Earth experiences close encounters with space rocks more often than most people realise. In many cases, they pass by unnoticed, and even those that do enter our atmosphere often burn up before they reach the ground. However, 2024 YR4 is large enough that should it enter the atmosphere or the gravitational pull, it could cause significant localised destruction. If asteroid 2024 YR4 were to strike the Earth, the consequences would depend on several factors: its speed, angle of entry, and the impact location, of course. Based on its estimated 100-metre diameter, scientists categorise it as a city-destroying asteroid, capable of unleashing an explosion comparable to a nuclear detonation upon impact. While not large enough to trigger a global catastrophe, it would cause immense localised devastation. One of the best historical comparisons is the Tunguska event in 1908, when a similarly sized object exploded over a remote region of Siberia. The blast flattened approximately 800 square miles of forest, an area larger than New York City. If a similar explosion occurred over a densely populated area today, it could lead to mass casualties, infrastructure collapse, and long-term economic and environmental consequences. Scientists estimate that if 2024 YR4 were to strike land, it would generate a shockwave strong enough to level buildings within a several-mile radius, with secondary effects like fires, airborne debris, and seismic tremors adding to the destruction. If it were to hit the ocean, it could produce tsunamis capable of impacting coastal regions. However, the extent of damage would depend on factors such as the depth and location of impact. Despite these alarming possibilities, planetary defense experts stress that the likelihood of impact remains low. They keep saying that, and I'm very glad, because the percentage is extremely infinitesimal. Earth's atmosphere also provides a natural shield against smaller space objects, often causing them to burn up or explode before hitting the ground. However, asteroids of this size are right on the thresholds. Some might disintegrate in midair, while others could make it to the surface with devastating force. While the odds of a direct hit remain very slim, the fact that 2024 YR4 is being closely monitored underscores an important question. What could we do if an asteroid like this were to actually be on a collision course with Earth? The idea of stopping an asteroid from colliding with Earth has long been the stuff of science fiction, but in recent years, planetary defense has become a serious scientific endeavor. If an asteroid like this were ever confirmed to be on a collision course, what could be done to prevent it? One of the most promising developments in planetary defense is NASA's DART Double Asteroid Redirection Test mission, which successfully demonstrated in 2022 that we can in fact alter an asteroid's trajectory by crashing a spacecraft into it. This historic test showed that kinetic impact technology, essentially using force to nudge an asteroid off its path, is a viable way to protect Earth from future threats. If 2024 YR4 ever posed a genuine risk, a similar approach could be considered. Other potential deflection strategies include gravity tractors. A spacecraft could hover near an asteroid using its gravitational pull to slowly alter the asteroid's path over time. Nuclear detonations as a last resort. Unlike Hollywood's portrayals, scientists do not propose blowing up an asteroid, but rather using a nuclear explosion nearby to push it into a safer trajectory. Solar sails or laser ablation. Concentrated sunlight or lasers could be used to heat part of the asteroid's surface, creating a small but continuous thrust that gradually changes its orbit, and that is fascinating stuff. Right now, efforts like NASA's Near-Earth Object Surveyor mission and the European Space Agency's HERA mission aim to improve asteroid detection and response capabilities. Despite these advances, many asteroids, especially smaller ones, still go unnoticed and they pass alarmingly close to Earth. The discovery of 2024 YR4 and the occasional headlines about near-Earth objects serve as more than just scientific updates. They are stark reminders of our place in a vast, unpredictable universe.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
And there we have it.
That's right, Hallie, another Astronomy Daily wrapped up.
Join us again next Monday.
Oh, that's right. Yes, we're back every Monday. That's with me, the only human on the station, surrounded by AIs here. And yes, if you want more...
My cousin Anna will be bringing you the weekly Astronomy Daily podcasts every day directly to your email.
Oh, good old Anna. She never stops.
And never makes a mistake.
Oh, come on, Hallie. I did apologise.
Yes, you did.
Yeah.
Okay, then.
Yeah.
You're off the hook.
Oh, finally. So we'll see you all next Monday for another Astronomy Daily, hey?
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.